And notice they gave us some values here. Okay. The three that we're going to talk about is R, M, and B. Okay. Well, we know what M is, right? M is the slope. This is what goes right in front of the X. And B, that's our y-intercept. Okay. Our y-intercept is at negative 16. So if I back out a little bit, you can see that it goes through right about here, which is about negative 16. Okay, but we want to see our data points. And this R represents the accuracy of this line. Okay, the closer it is to 1, if R was 1, all these dots would be right on the line. It would be exact. Okay, so basically it's saying that it's like 91% accurate. Okay, the closer it is to 1, the closer it is to being 100% accurate. Okay, I'm going to go ahead and go back to our problem here. So create a scatter plot. We did that using the line of regression. Record the information on your calculator screen, then use that information to write the regression equation. Round to the nearest hundredths place if necessary. So I'm going to go ahead and do this here. Oops. And I'm going to go ahead and record this information. So the three things that I want you guys to record, one of them is R. R is 0.91. This is round to the nearest hundredth, so 0.91. I guess I should write a 0 in here. And I'm going to put some spaces in here so it looks a little nicer. Okay, we also know that M is equal to point. Now remember, we're rounding to the nearest hundredth. So this 8 is going to bump up this 8 to a 9. So our M is 0.39. So I'm going to go ahead and type that in. And one last important value to us is B. And that value is negative 16.56. Okay. So right now, this information is the most important for us. Okay. Now let's go ahead and look at what else they wanted us to write. So let's create a scatter plot. We did that. Record the information on the calculator screen. We did that. Then use the information to write the regression equation. Round to the nearest hundredths place if necessary. Okay, again, so we know that our normal equation is y equals mx plus b. Okay, but we know two different things. We know that, let's see, we're going to go ahead and write our equation here. Y is equal to, we know what our m is. M is going to be 0.39. So instead of m, I'm going to type in 0.39, 0.39. X plus, and we know what B is. B is negative 16.56. So I'm actually going to change this plus to a minus because we have a negative value here. So I'm going to go ahead and change that to minus 16.56. All right, let's go ahead and look at number 3. Write your equation in context, replacing the variables with the labels. So we're going to replace x and y. So let's go ahead and look at our tables up here. Our x-axis represents height in inches, okay, on both of these graphs. The y-axis is the shoe size. So we're going to replace x with height in inches, and we're going to replace y with shoe size. So let's go ahead and type this out. We're going to use this equation, but instead of y, we will use shoe size. So instead of y, it's shoe size equals 0.39, and instead of x, what am I going to use for x? What did x represent? You can see it right here. This is our x. These are our x values, so height. Number 4, describe the correlation between the height and shoe size. This is related to the R value shown on your calculator screen. Okay, so we had a 91% accuracy. Okay, so the correlation is pretty strong. 91 out of 100. Okay, because 0.91 is if you turn that into percent, it's 91%, and 1 is 100%. Okay, so this is very close to 1. Okay, I look at it as 91%. Okay, that's pretty strong. So we're going to say that it has a strong, I'm going to say positive because our slope is going up. It has a strong positive correlation. Okay, before I answer number 5, you guys will need to go to the next video.